Hello. In this problem, we are given this function y equals x minus 2 over x plus 1, and all of it is raised to the power of 6. Now the problem asks us to find the derivative of y with respect to x, with one restriction, that we are only allowed to use the power rule, the rule for integration of constants, and the chain rule. Nothing else. How will this affect our process? Well, we'll see. Either way, let's get started. So the first thing we'll note, if we want to take advantage of the chain rule, because it does look like that's what this will be. We've got a function raised to the power of something. So it looks like we can use the power rule pretty quickly. So the first thing I'm going to do is, let's define a new variable a. And let's say that a is equal to x minus 2 over x plus 1. And this means that we can rewrite y as equal to a to the power of 6. Now let's re-examine the chain rule real quick, just to remind ourselves of what we're doing here. So we're given a function, dy with respect to dx, or rather we're told we want to find this derivative, dy with respect to dx. And now we've rewritten y in terms of some new thing, a. So let's say that dy over dx is going to be equal to dy over dA, so the derivative of y with respect to a, times something. I'm going to leave this multiplication symbol here because we're not quite done with this yet. Because remember that the whole idea behind the chain rule is that in order for this to be truly equal, in order for this equation to be complete, we must also have the derivative of a with respect to something that will lead us to x. Because that's how the chain rule works, and that's how we'll be able to find the answer to our problem here. So first off, let's figure out what the derivative of y with respect to a will actually be. And we can see, using an application of the basic power rule, that dy with respect to dA will simply be 6a to the power of 5, where just the a is risen to the power of 5, because that's how the power rule works. We still want to find a. So now let's try and take the derivative of a with respect to x. Because, think about it, if we can do that, if we can take the derivative with respect to x, then that will make this chain rule sequence easy. Like, it'll make it valid, and we'll have something equivalent to the derivative of y with respect to x. So let's try doing that. So I'll give myself some more room here. So let's try taking the derivative of a with respect to x. So looking at our function for a here, we can see that we've got some x terms at the top in the numerator, and some x terms in the bottom in the denominator. So it looks like, since the variable we're differentiating with respect to is in both the numerator and the denominator, it looks like we're going to have to use the quotient rule. So fortunately, it's pretty easy to do in this simple case, except for one problem. The problem tells us we're only allowed to use the chain rule or the power rule. No quotient rule, no product rule, meaning we can't use this method. So from the looks of that, with that stipulation that we can't use the quotient rule, suddenly this looks much harder to differentiate. So we're going to have to use another method here. And what I'm going to do, that I think will simplify this function down a bit, is I'm going to define a second variable, let's call it b, and let's try and rewrite this function for x in terms of b. If we can do that, then we might be able to get a much simpler function that we can differentiate, and then see where we can go from there. So let's see. So if we want to simplify this function down a bit so that it's easier to differentiate with respect to a single variable, I'm going to say that b is going to be equal to the denominator, x plus 1. Because if we have a single variable in the denominator, then that means we'll be able to expand the numerator with more freedom, as per our algebra rules. So if b is equal to x plus 1, then by the same token, x will be equal to b minus 1, because we get that by taking this right here, and then subtracting 1 from both sides to solve for x. So now let's try rewriting a, or rather rewriting x minus 2 over x plus 1, in terms of b. So let's see, b is what is equal to x plus 1, which is what we have in the denominator. So whatever a is, it's over b. And in the top, in the numerator for a, we've got x minus 2. And as I can see from our algebra here, I've written x as equal to b minus 1. So in the top, we've got b minus 1, because that's the stand-in for x. And then we're also subtracting 2, since that's a separate term from the x. All right, so b minus 1 minus 2 all over b. Simplifying this down a bit, we get b minus 3 in the numerator, since negative 1 minus 2 is negative 3. And b is still in the denominator. And since we only have one term in the denominator, we can expand this out a bit as b over b minus 3 over b. Now b over b is, of course, 1 minus 3 over b, which can be just written as 3 times b to the power of negative 1, since that's what it'll be equal to just take b out of the denominator. So now that we have a rewritten as a function that's much easier to differentiate, let's try taking the derivative of a with respect to b. So d over db is going to be equal to the derivative of 1, which is a constant, so it's just 0, plus the derivative of minus 3b to the power of negative 1. So if we're differentiating with respect to b, then this is pretty easy to solve for in terms of the power rule. So we'll take this negative 1 at the top here and multiply the entire term by that, which doesn't do anything other than cancel out the minus sign, so that'll be a plus 3b. And as per the power rule, we take the power and subtract by 1, so that will become raised to the power of negative 2. So dA over dB is equal to 3b, positive 3b, to the power of negative 2, which can be written as, perhaps even more simply, as 3 over b squared. So now we've got this lovely function for the derivative of a with respect to b. So let's amend our chain rule function here a bit more. Now it's dy over dA times dA over dB, but we still need to get something with respect to x. So whatever we'll do next is we'll have to take the derivative of dB with respect to something. And we've got a function for b right here with respect to x. And this is a very simple function that is easy to differentiate, x plus 1. So it seems like we're in the home stretch now, because dB over dx is quite simply the derivative of x with respect to x, which will just be 1, plus the derivative of 1, which is a constant, so it just turns to 0. We can leave it b. So this is our derivative with respect to x of b. So that gets added to our chain rule now. So now we've got our full chain rule function all finished. dy over dx is equal to dy over dA times dA over dB. See, the dA's cancel out now. dA over dB times dB over dx, and the dB's can cancel out now. So it's very easy to see now from this that our whole thing is equal to dy over dx. Now let's actually substitute in all the individual functions we created. We know that the derivative of y with respect to a is equal to this term up here, 6a to the power of 5, times the derivative of a with respect to b, which we found as 3 over b squared, times the derivative of b with respect to x, which is just 1. We don't even really have to write it, to be honest. Now let's simplify a little bit. As I just kind of said, the 1 can sort of disappear because it doesn't change anything. And this constant 3 can multiply by the 6 to simplify this as 18 times a to the 5th power times 1 over b squared. Now let's substitute in what we set a and b equal to. I guess I'll do this down here. The value we set a equal to is x minus 2 over x plus 1. So that whole thing is raised to the 5th power. So that'll be x minus 2 to the power of 5 over x plus 1 to the power of 5 times 1 over b squared. And we set b equal to x plus 1. So that's times 1 over x plus 1 squared. And now finally, to simplify it even further, we can notice that this x plus 1 is the same in both denominators, so we can multiply them by each other, and we've got it raised to the 5th power in this term, and it's squared in this term. So they can add up to make 18 times x minus 2 to the power of 5 in the numerator, and x plus 1 to the power of 7 in the denominator. And without using a calculator or any other tools, it looks like this is about as simplified as we're going to get it. So this is our derivative of y with respect to x. And now you can plug in whatever value you have given for x, and you'll be able to find the derivative of the function at a particular value.